Hey everyone. So here's our first lesson of 20-2, and it's going to be a factoring review. Now, I gotta tell you, do you ever have one of those days? We all have those days. I had one of those days the other day when my first 20-2 class that came in, this was the plan, and I wasn't paying attention because they had an assembly, and I gave them the 20-1 factoring review note, not the 20-2 factoring review note. Nobody told me. Anyway, this is the right one. These are the right questions, and it follows your book, so that's awesome. If you don't have a book at home, you'll have all the questions on the PowerPoint, so don't worry about that at all. Factoring was one of the most important things we talked about in grade 10, one of them, and it's one of the things from grade 10 that carry on into your grade 11 and 12 courses in both the -1 and -2 stream. The difference in grade 11 and 12 is now going to be that, for instance, in grade 10, the question was just factor this, okay? In grade 11 now, you have to factor to get to whatever you're doing. Factoring becomes the process to answer a question instead of the actual question itself, okay? So it's really, really important that you understand factoring. I'm going to go through kind of the basics with you here again, but if you follow through on this note with me and you leave still kind of stressed out, still kind of confused, I would encourage you to go back. I do have 10C videos already on YouTube. So go back to YouTube and just search my name and factoring and watch some of those videos that would come up with factoring, okay? Again, my name is Peter Hill, just in case you forgot that. Okay, so factoring review, here we go. Expand means to form a product. I'm just going to hide my face so you can see these words. This usually involves getting rid of brackets and combining like terms. So when we go to expand something, I am taking the 2 and multiplying it by x and the 2 and multiplying it by 7, and that's going to give me 2x plus 14. So we have gotten rid of the brackets by doing the multiplication. When there's nothing in here, like right there, there's no symbol there, it's just touching a bracket, okay, that refers to multiplication. So 2 bracket x plus 7, you are looking at a multiplication sentence. It's saying 2 times x plus 7, okay? So to expand means do that multiplication. To factor means create the multiplication statement, okay? So if you look down here, I've got 2x plus 14. Well, that's not a multiplication statement, that's an addition statement, okay? I can create a multiplication statement by taking the 2 out of each of these terms. So if I took the 2 out and say what I'm left with, 2x, if I take that 2 out and I take that 2 out, okay? I'm gonna say this a couple times probably, but I might as well start right now. Take note that 2 doesn't disappear, okay? It just goes to the front. I'm not making it go away. I'm just pulling it to the front so that I can create a multiplication statement, okay? So that's going to give me x plus 7 on the inside. And so now I just want to switch my colors here for you. I took a addition statement and turned it into a multiplication statement. When I create that multiplication statement, that's called factoring, okay? That's what factoring means. Okay, cool. So factoring and expanding are inverse processes of each other. What that means is they're the opposite direction. They undo each other, okay? The opposite of factoring is expanding. The opposite of expanding is factoring. So what we want to do is just walk through some strategies together, okay? The first one is about taking the greatest common factor out. Now, that's analogous to what I just did in that last example where I took the 2 out. 2 was common. It was a factor that was common to both of those terms. And so I pulled it to the front and I opened up a set of brackets and I stated what's left. No matter what the factoring question, that should always be your first step, okay? You should always look for a greatest common factor. So let's look at these 3 terms here. We've got a 10x squared y5. We've got a negative 35x cubed y to the 4. And we've got a 5x y squared. And we want to think, okay, what's the biggest amount that's common to everything? Well, let's start with the numbers. I've got a 10, a 35, and a 5. All of those are divisible by 5. So I know I want to take the 5 out. Okay. I've got an x squared here. X squared is like x times x. Okay. X cubed is like x times x times x. So there's 3 of them sitting in that pile. And then I've got 1x here. So when I think about all my x's in each of these terms, there is at least 1x that's common to everything. Okay, so I'm going to take that 1x out, pull it to the front. Then I've got here, I'm just going to switch colors here. I've got 5y's and 4y's and 2y's. Well, how many are common to all of them? There'd be 2y's common to all of them. Okay, so I can take out a y squared. Okay, so now what I have to do is I have to state what's left when that comes out. So what happens essentially is each of these terms, 1, 2, 3, are going to get divided by the thing I'm taking out, which is 5x y squared. So when I divide 10 by 5, I'll get 2. When I divide x squared by x, remember that, go back to your exponent laws, when I'm dividing powers of the same base, I would subtract the exponent. So x is like x to the 1. 2 minus 1 is 1. So x squared x squared divided by x is just x. 2 minus 1 is 1, okay? And then x or y to the 5 divided by y to the 2 would give me y to the 3. Okay? Then I do that for the next guy, negative 35 divided by 5. Every term that I'm doing has to get divided by the greatest common factor that I took out. Okay, so negative 35 divided by 5 is negative 7. X cubed divided by x will give me x squared. That's like a 3 minus 1. Y to the 4 divided by y squared will give me y squared. That's like a 4 minus 2. And then you got to be really careful with this last term. It's 5xy squared divided by 5xy squared. Lots of kids leave it and say, oh, that's gone. Yay. Nothing's ever gone. Okay, you got to be careful with that. Anything divided by itself is 1. 7 divided by 7, 1. 11 divided by 11, 1. 18,000 divided by 18,000, 1. So that ends up being plus 1. However many terms that you start with in the question, this original question was 3 terms. When you're pulling out a greatest common factor, there should be the same amount of terms inside that bracket. Okay. Now, I'm going to go through the next 2 examples here a little quicker. I'm not going to draw them out for you. But remember, you are watching a video right now. Pause it. You try things yourself and then compare your answers with me. Okay. If you miss something, make sure you rewind it. Make sure you slow me down if you need to. Do what you need to with these videos to make sure you walk away with the best understanding you can possibly have. Okay. All right, let's look at the second one. Negative 5x squared y plus 25x cubed y4. Now, if the front term is negative, you should always take the negative out. So part of my greatest common factor here, I'm going to have my greatest common factor to be negative. Okay, so I'm going to take out a negative 5. 5 and 25 both have a common factor of 5. X squared and x, I can take out an x squared. Sorry, x squared and x cubed, I meant. Okay, x squared and x cubed. I can take out an x squared. And then y and y to the 4, there's one y that's common. So my greatest common factor is negative 5 x squared y. Take that out, and I'm going to be left with 1 minus, when I take 25 and divide by negative 5, just be careful of that. That's going to change the sign. So that's going to be negative 5, right? That's why I said minus. Then we have x cubed divided by my x squared. So that'll be x. And y to the 4 divided by y will give me y to the 3. So I end up with negative 5 x squared y times 1 minus 5xy cubed. Okay. All right, this next one at the bottom here is kind of fun. what I need you to see here is this and this is the same thing. They both say x minus 4. So there's a common factor here. If I had said xa plus 1a, you would have said, hey, a is a common factor. Let's pull the a out. So let's write a times x plus 1, right? You totally would have done that. Okay, so look at it as the same way here. X minus 4 is a common factor, so I'm going to pull the x minus 4 out. And when I do that, I'd have x minus 4 pulled out to the front, and what would I be left with? I would be left with the x plus 1. Okay, so x minus 1 got pulled out to the front, leaving me with the other terms, which is x and a 1, just like I did right here. Okay, awesome. Okay, so that was a bit of a review on taking out the greatest common factor. Now we're going to switch to factoring trinomials. Now, there are many different ways you can factor trinomials, and it doesn't matter to me what you did. Maybe your teacher taught you cross-product method, decomposition. You can write them as an area model and factor all the directions of your rectangles out. That's another good way to do it. You could do it by inspection, where you just understand how the system works. Doesn't matter to me. Okay, I'm going to walk these examples through with you through the process of decomposition, because kids who struggle with factoring, decomposition, I think, is one of the easier things to kind of grasp a hold of the process. So that's what we're going to do. But if you know how to do it another way, totally fine. Okay, so what I'm going to do is I'm going to look for two numbers that multiply together to give me the outside numbers multiplied together. Okay, so I've got a 1 times -6 there. So that would be a -6 I'm looking for. And then I'm going to add to the middle number, which is -5. So what I want to do is I want to go through my factors of 6. I know what that would be: 1 times 6 and 2 times 3 and 3 times 2, but I don't need to say that because it's already there, right? Order doesn't matter with multiplication. Now, I need to multiply two numbers together to get a negative number, so I know one number has to be negative. And I need to add to get a negative number. That tells me my larger number has to be negative. So I'm going to put a negative here and a negative here. And I'm going to say, okay, which one of those is going to give me the -5 that I look for? Oh, this is the pair that's going to be friendly to me. 1 times -6 will give me my -6. And 1 plus -6 is going to give me my -5. Okay, so what I do, this is called decomposition, because I break down the -5 into those friendly terms. So I'm going to write this as x squared. Just going to put it on as my ink here. Okay, x squared minus 6x plus x minus 6. Okay, so my -6x and my x make that -5x. So I haven't changed anything in the equation. I just broke down my middle term into those two friendly terms. Now, what I want to do is factor the front two and factor the back two. Okay, so I'm taking out a greatest common factor. What's common between x squared and -6x? Well, an x is common there. So if I took out that x, it would leave me with, just like I did on the previous slide, right? Now I'm just taking out a greatest common factor. That's going to leave me with x minus 6. And then here, I got to take something out, but I see it's exactly what I want, and I see there is nothing to take out, so that tells you take out a 1, just so you can finish the process. So that would be plus 1, which is x minus 6. Okay, and then my heart goes pitter-patter because I have the same thing in the brackets. I see that x minus 6 in both sets of the brackets. That means this is a greatest common factor, and I can pull out the x minus 6, just like I did on that last example. Okay, so that would leave me with x plus 1 and x minus 6 multiplied together. Okay, kids often ask me, does it matter the order of the factors? This is x minus 6 times x plus 1. I said x plus 1 times x minus 6. No, 2 times 3, 3 times 2, the order doesn't matter with multiplication, so it doesn't matter which factor goes first. Okay, okay, now some of you may have looked at this and said, oh, that Hill is an idiot because this is a shortcut. You could have just gone right to x minus 6, x plus 1. Sure, you could. And if you understand that, go for it. At this stage of the game, when we're just introducing this stuff, I'm not a big fan of throwing shortcuts at you because I don't want it to muddy the waters or muddle your head. Decomposition will always work. When you see other things and you're comfortable to go for them, go for them. But these examples I'm going to do with you right now, I'm just going to focus on decomposition. Okay. All right. So let's look at the next one as well. X squared minus 16x plus 28. I'd be looking for two numbers that multiply together to give you 28 and add together to give you negative 16. So again, you want to go through your factors of 28. So I've got 1 times 28. I know both of these numbers are going to have to be negative this time because I need to multiply to get a positive, but I need to add to get a negative. 1 and 28 won't work. 2 and 14, hey, that's going to work right there. 2 and 14 is 16, so negative 2 and negative 14 is negative 16. Okay, so I found my friendly numbers. I'm going to decompose my negative 16x into the negative 14x and the negative 2x. Okay, now I've got those four terms. I'm going to factor the front two, factor the back two. Out of the x squared minus 14x, I can take out an x and I'll be left with x minus 14. Out of the negative 2x plus 28, a reminder, when the front term is negative, you should always factor the negative out. So I'm going to take out a negative 2, and then that's going to leave me with x minus 14. I'm excited. I see x minus 14 in both of those. So the x minus 14 can get pulled to the front, and I'd be left with x minus 14 times x minus 2. Okay? Awesome. Okay, let's try these two. Make sure you're pausing me and trying them yourself. Everything's easy when you watch somebody else do it, right? You should pause. You should try and struggle through this and then compare your answers with mine and compare your steps with my steps, okay? If you're doing decomposition, our work should look very, very similar. So 2x squared minus 9x minus 5. I'm looking for two numbers that multiply together to give me negative 10. Remember, you have to multiply these outside guys together. And add together to give me negative 9. So that's going to be negative 10 and positive 1. So I broke my negative 9x into negative 10x plus x. Now I'm looking to factor the front two and factor the back two. On the front two, I can take out a 2, and that's going to leave me, a 2x, and that's going to leave me with x minus 5. On the back two, there's nothing to take out, so I take out a 1, which leaves me with x minus 5. I get super excited because my x minus 5 is common to both of these terms. So I pull the x minus 5 out, and I'd be left with 2x plus 1. So my final answer would be x minus 5 times 2x plus 1. Now, don't lose what we're doing here. We started with a statement of addition and subtraction, and we changed it to a multiplication statement, okay? That's what factoring is all about. Factoring means we're creating the multiplication sentence, okay? Okay, 6x squared plus 13x plus 5. Hopefully you've already done this because you paused me earlier. That's two numbers that multiply together to give you 30, 6 times 5, and add together to give you 13. That's going to be 10 and 3. So I've split out my 13x into 10x and 3x. Students often ask, should I do 10 first and then 3, or 3 first and then 10? Doesn't matter. Okay, you'll get the same answer regardless. Okay, so 6x squared plus 10x, I'm looking for a greatest common factor. I can take out a 2x there and be left with 3x plus 5. Taking out a 1 from the back and be left with 3x plus 5. So now my heart goes pitter-patter because I have that 3x plus 5 as a common factor to both of these terms. I can pull out the 3x plus 5 and be left with 2x plus 1. Okay, we got this, guys. We got this. All right, let's try again. X squared plus 10xy plus 24y squared. Now this one looks a little different because of the y squared on the other end. It is totally okay to have the square on the other end as long as you have half of it in the middle. If you have half of it in the middle, it's still a friendly trinomial. We can still go through the process of factoring by decomposition. So I'm looking for two numbers that multiply together to give you 24 and add together to give you 10. Of course, by now you've already paused me, right? You've already tried this yourself. You're now comparing your answers with my answers. Those two numbers are 4 and 6. So I'm going to split my 10xy into 4xy and 6xy. Whatever goes after the number, oh, I shouldn't have green on green there. Whatever goes after the number needs to go after the two friendly numbers that you have as well. So make sure you're consistent with that. Okay, now I'm going to factor the front two and factor the back two. In the front two, I can take out an x, and I would be left with x plus 4y. In the back two, I can take out a 6y, and that would also leave me with x plus 4y. Okay, so super exciting. X plus 4y is a common factor to both, so I can pull the x plus 4y out and be left with x plus 6y. So my multiplication statement is x plus 4y times x plus 6y. Okay. The next one on this slide, 2x squared minus 3x minus 5. I'm looking for two numbers that multiply together to give me negative 10. Remember, you have to multiply the outsides together. So 2 times negative 5 is negative 10. And add together to give me negative 3. That would be negative 5 and positive 2. So I break my negative 3x down into negative 5x with a positive 2x. Factor the front two, factor the back two. From the front two, I can take out just the x, and I'd be left with 2x minus 5. On the back two, there's nothing to take out, so I just take out a 1, and I'd be left with 2x minus 5. Super, I've got that 2x minus 5 common to both, so I'll pull out the 2x minus 5 and be left with x plus 1. Okay, fantastic. The next sort of factoring conversation that I want to have with you is around a difference of squares. Now, a difference of squares is a binomial, so there's only 2 terms, not 3 terms. And often, these, for whatever reason, are things that kids have a very hard time seeing when they're in the middle of doing questions. Okay, so you always want to look for difference of squares. A difference of squares means, remember in math, the word difference refers to subtraction. Okay, just like the word product refers to multiplication, difference refers to subtraction. Sum refers to addition, and quotient refers to division, just in case you want the other ones as well. Okay, so it's a perfect square minus a perfect square. So what happens is, it would look like this format. We'd have a squared minus b squared. Okay, that's a perfect square minus a perfect square. And it always factors into 2 things multiplied by each other, 2 binomials multiplied by each other, where the first item in your binomial will always be the square root of the first item of the question. Okay. The second or the last item of your binomials will always be the square root of the last guy of your question. And then one of them gets added together and one of them gets subtracted. Okay. So let's try a few of these guys. So x squared minus 16, I do have a subtraction there. X squared is a perfect square. 16 is a perfect square. So what I do is I set myself up to say, okay, it's going to look like this. The square root of x squared is x. So that means x has to go in the front. The square root of 16 is 4. So 4 has to go in the back. And then one of them gets added and one of them gets subtracted. So I end up with x plus 4 and x minus 4. Okay. Okay, you try the next one. 9x squared minus 25. You want to ask yourself, do I have a perfect square minus a perfect square? If this had said 9x squared plus 25, then no bueno, there's nothing to do. Okay. But because it says minus, then it's a difference. It's a subtraction of 2 perfect squares, and I can do this factoring process. So that's going to give me 3x plus 5 and 3x minus 5. Okay, then this last guy here, 8d squared minus 32. Well, that sucks. 8's not a perfect square. Always look for greatest common factor first. I said this a few minutes ago when we started with greatest common factors. I said, hey, this should be the very first thing you do with every factoring question, no matter what the question. 8d squared and minus 32, there's a common factor of 8 there, so I can take the 8 out. If I take the 8 out, I'm left with d squared minus 4. Now that's fantastic because d squared minus 4 is a difference of squares. That's going to factor into d plus 2 and d minus 2. But what you have to remember there is don't drop the 8. The 8 is along for the ride for the rest of the time. Okay, so my final answer would end up being 8 d plus 2 and d minus 2. 8 times d plus 2 times d minus 2. Okay, so as a little summary here, to factor completely, these are some of the things you're looking for, okay? First of all, you do want to simplify through addition and subtraction of like terms. If you have a 2x squared and a 2x squared in the same sentence, you want to change that to a 4x squared first. Combine them before you try to start factoring, okay? Look for the greatest common factor. We were just talking about that. Or for grouping to form a product. So when we say grouping, that's where we're looking at, like if you had that x plus 4 as a common factor to both, okay? And then look for trinomials and look for difference of squares, okay? So we'll round up our conversation with these last 3 examples. You pause me first and give them a try, and then come back and I'll show you the answers, okay? All right, welcome back. 2x squared plus 4x plus 12. Remember, first step is always the greatest common factor. So the very first thing I want to do is take out that 2. 2 is common to all of them, okay? So I take out the 2 and I'm left with x squared plus 2x plus 6. Now I want to look at this and say, okay, can I keep going? The whole purpose of factoring is to completely factor. So you want to ask yourself, is there more to do? You keep going until there is no more to do. So you're going to ask yourself a question. You're going to say, hey, do I know 2 numbers that multiply together to give me 6 and add together to give you 2? Okay, well, I could do 1 times 6. Let me write that down for you. I could do 1 times 6, or whoops, that's a bad 6, guys. Okay, and 2 times 3. Neither of those are going to be able to get me a 2. Okay, so that just means I'm done. The purpose of that question was just to take out the greatest common factor. Everything's rosy. The question's done. Okay, next, 75x squared minus 12. Well, none of that looks familiar, but let's see if we can find a common factor. There is a common factor. It's 3. So pull the 3 out and see what happens. If I pull the 3 out, I'm left with 25x squared minus 4. Well, that's a difference of squares, my friends. So that's going to give me 5x plus 2 and 5x minus 2. So I'm left with 3 times 5x plus 2 times 5x minus 2. Okay? You guys are doing awesome. Okay, last one looks super confusing, but it's just that we got to clean it up first. And look at this, 2x squared minus 2x squared. That's going to give me 0, so that's actually gone. 3x plus 17x will give me 20x, and negative 8 plus 20 will give me 12. So when I combine all like terms, I'm going to end up with 20x plus 12. So now I'm just looking at factoring that, just looking for a greatest common factor, which would be 4 here. And then that would leave me with 4 times 5x plus 3. Okay. See, factoring doesn't have to be too scary. Do lots of practice, okay? That's the best way to handle this. So if you are one of my students at school, this is the homework that would go with this note. As always, please know that I'm here to answer your questions. So if you're struggling with anything, please make sure you come and connect with me, okay? We are all in this together, and we're going to figure it out together. All right, I will see you for the next note, which is when we get into actual quadratics. It'll be super fun. You'll need a graphing calculator for that too, so make sure you've got that with you before you go click on that video. Okay, take care, guys.